Alright, this is part 2 of the introduction video, introduction to functions video that I started on a previous video. So let's continue. It says evaluating functions. To evaluate a function for given values of x, replace x in the function with the input value and simplify the right side, or right-hand side. So we have f of x equals 4 minus 3x. And g of x equals x squared minus 2x. So the way I always suggest or recommend students do these is first make a shell of the function. So for f of x, I'm basically replacing x with parentheses. So here I have x and here I have x. And so that's where I'm going to have parentheses down below. And so I'm just making a shell. Now my input here is 2, so I'm going to replace or put 2 in where x was. And so now I just need to simplify the right side. It's 4 minus 3 times 2, or 4 minus 6. And so I get negative 2. So when my input, or x value, is 2, my output's going to be negative 2, or that's also a y value. Remember, what we have here is f of 2 is equal to negative 2. And I also know one other thing, and that is that 2 comma negative 2 would be a point on the graph of f. All right, let's move on to part B. So again, make a shell. Again, this is the f function, so it's just like the one we just did. But this time I'm going to substitute x minus 5 wherever x was. So for some people this is a little strange because we have an x in this, but doesn't matter. We're just going to plug in whatever our input is wherever the parentheses are. So now we have a little bit of simplifying to do on the right side. So I'll distribute there, and then I need to combine the 4 and the 15. We're going to end up with 19 minus 3x, or you could write it as negative 3x plus 19. So my input was x minus 5, and my output was negative 3x plus 19. It doesn't have to be a nice number like what we got on part A. Now be careful when you get to C, because now we're working with the g function. So let's set up a shell using the g function. Let's replace our x's with negative 3. And then we just need to simplify this. We got negative 3 squared, which is 9. And that's going to be plus 6, which is 15. And let's do the same thing to find g of negative x, or g of minus x. So let's plug in our negative x's. So a minus x times a minus x, that's going to be a positive x squared. And a minus 2 times a minus x is going to be a plus 2x. And that's all we've got to do there. So now on number 8, our function is a set of ordered pairs. So to find f of 1, think about the fact, or think about what the 1 represents. It's an input or an x value. So I need to find the point that has an input or x value of 1. That would be this one. So here the output would be 16. On part B, I need to find f of 12. So this time I have an input of 12. So I need to find the point that has an input of 12. And the output there is going to be negative 10. Now letter C is kind of backwards. We have, in fact, this time we're given 24. That's not our input. The input would be the x here. So we weren't given the input, we were given the output. So we need to look for any points that have an output of 24. There's actually 2, or 2 points that have y values of 24. And so those points have x values, or inputs, of 9 and negative 11. So it's kind of the opposite, basically the opposite of what we just did for A and B. All right, let's move on. So on number 9, let's see, we have to find h of negative 3, and we're given a graph here of some function. We're calling it h of x. So h of negative 3, we're given an input of negative 3. So we need to find the point that has an x value, or input, of negative 3. That would be this point right here. right? Because we're 3 to the left. That point actually has the x value -3 and the corresponding y value of -1, which tells me h of -3 is -1. Now another way to say this is when x is -3, which happens right here, the height of the graph, well, it's down 1. So that's another way to think of the same thing. Look at part B. So this time my x value or input is -8. So I need to find the point on my graph, that's this graph here, that has an x value of -8. So that would be this point here. So the coordinates here are -8, 4. So h of -8 is 4. Now again, another way to think of that is when x is -8, whoops, let's try this again. When x is -8, what's the height of the graph? Well, notice that the graph is up 4. And so, oops, we get, oh, I lost something here. Hold on a sec. I need to put in, hold on, sorry about this. I don't know what happened there, but let's make that into a 4. Okay, so next we have h of 2. So this time we are looking where x is 2, which happens right here. And the height of the graph there is 2. Or you can also think of it as the point on the graph that has an x value of 2 has a y value of 2. So h of 2 is equal to 2. All right. Last one. Notice this time we're given the output, not the input. This is a y value. So we need to go to the graph and look for any points that have a y value of -5 when we look on the graph. Now one way to do this is to draw a horizontal line through -5. And notice there's 2 points on my graph that are down 5, basically, or have a y value of -5. Here's my points. Notice both of these points have a y value of -5, so the corresponding x values are -5 and 5. All right, and that's going to be it for this video.